Hello everyone, here's JJ. So this video is also for DP2 student, but if you're interested in, you can watch it. So I wanna explain why when we want to solve differential equation like y derivative plus px y equals to qx. When we try to solve this equation, we have to time e to the power of indefinite integral of function px. Why we have to time this factor? Why we have to time that? I mean, if you look at the mark scheme, after you time this factor to both sides, then for the left side, you can simplify. Yeah, actually, it's all by explanation. Because look at this. Y factorial times e to the power of plus y times px e to the power of indefinite integral of px dx. Okay. Is equals to qx times e to the power of indefinite integral px dx. The thing is, doesn't matter what is px. E to the power of indefinite integral of px dx at the end is still a function about x. So on the right side is still something about x. Only related to x. Let's look at left side. So y factorial y px e to the power of indefinite integral of px dx. Since there's a px e to the power of px dx, indefinite integral of px dx. How is that special? So, you guys remember? I mean, if you really go through the mark scheme, then you will see for the left side, there's such a thing like u derivative v plus uv derivative is equals to u times v, then whole thing derivative. Then actually we can check, because you see it is a y derivative, it is a y. Let's check. Okay, y, if we think y derivative is the u in the formula and y is the u, then it means e to the power of indefinite integral px dx is the v, and the thing here will be v derivative. So let's check. So e to the power of indefinite integral px dx, let's calculate the derivative. So it's equal, we can use chain rule or onion rule. Why is onion rule? Because such a thing is like, it is a function, it is from e to the power of x is also a function. It's like put a function inside of function. So in order to calculate the derivative of this compound function, you have to peel each bracket, just like onion, peel it, then at the end you get the result. Why it's called chain rule is because the result is like dy over du times du over dx and blah 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 blah. Everything is like up down line dot up down line dot. So it looks like a chain. So if people code it like onion as an onion rule, it's because of the left side, the compound function f g h bracket x is because that's why, and chain rule is because of the right side. Okay, anyway, so it's equals to e to the power of px dx time integral px dx derivative. Obviously, we know that the derivative of this is equals to, okay, so we can continue to simplify. Which exactly the same here. So that's why. So that's why we have to time this factor. You know, this factor is it will perfectly form. After we time this factor, it will perfectly form an original function and derivative function. Exactly. However, it seems the video should end now, but I want to bring you guys to explore why it's like that. Okay, so let's explore how to get Euler factor. So right now, imagine that we don't know anything. So if you want to solve this differential equation, I mean the result should be y equal to something. However, equation is similar to equation. When we want to solve how much is x, we have to move everything about x to one side and everything without x to another side, and then at the end divided by the noise number, then we just get x equal to something. Similar to here. You try to get something about something time y, then we can divide the thing in front of the y. However, it's not possible because we have a y derivative. So we want to combine the thing at the left to something like, something related to something like something times y. So that's why we have that's why we think about this. Because there's already a y derivative, there's a y origin. So if we can find something to form the v and the v derivative, and at the end we can use this formula to simplify the left side to something times y, something times y derivative. Then later on we can use integral for both sides. Then we can get something times y is equal to something about x, or the something that's a v in this case is a factor we want to find. Then just divide by this thing here. Then we can calculate how much is what is y, right? So let's assume this factor is mu x. Okay, so we time mu x for both sides of the differential equation. So we get mu x and y derivative plus px times mu x times y equals to qx times mu x. Therefore, we hope it is y derivative, so it should be the mu x should be the origin and the origin function, and px and mu x should be the derivative of the function. So we can get this condition. So then we use this to divide by this, then we get v derivative over v is equal to px. Therefore, we can use derivative for both sides. And you guys remember? You see, it is v derivative. Okay, obviously v is equal to mu x is something, a function of x. So we can use, so we know that left side, we can assume like wait. we can assume, guys, du equals to v derivative dx. Therefore, we know that u is, then we know that v is equals to so there's a v derivative, and we assume du is equal to v derivative dx. Therefore, for both sides we can use integral. The integral of v derivative is equal to v. The integral of du is u. So v is equal to u. So for the left side, we will get derivative of 1 over u du is equals to integral of px dx. And therefore, we know that ln absolute value of u is equals to px dx. And u is equals to v, so we know that ln v equals to derivative of px dx. Therefore, if ln absolute value v is equal to this, and also because of the, therefore we know that e to the power of this is equal to e to the power of this. E to the power of ln v is equals to v, and for the right side is e to the power of integral of px dx. And we know that v is equals to mu x, then we know that mu x is equals to this. That's how the order factor comes from, like that. So that's all about this video. If you like this video, just follow my YouTube channel. And if you have any suggestions or have any questions, put it in the comments. So thank you very much.